all, you are visiting a nearby fruit market and you see that there is an offer going on. It says that whoever is solving the given puzzle will get a 250 gram of their favorite fruit as free. And the puzzle goes like this. There are 3 fruits available in the fruit market, and the total number of these fruits sum up to 106, in which the number of mangoes is 3 less than oranges, whereas number of apples is 4 more than mangoes. So we are expected to find out the number of mangoes, oranges and apples. All of us come across similar problems every now and then. Some might try to work out, some will ignore, some might Google to just know the answers. But basically, for most of us, the first thing that strikes our mind is that we will try to solve from known values to unknown values. Either we will try to substitute or we will try to eliminate. Say here in this, what we will try to do is, with the given values of mangoes being less by 3 with regard to oranges and mangoes is less by 4 with regard to apples, with these 2 values we will try to convert into a one equation with oranges and apples, and then we will substitute this in the original equation with the total number of fruits available, from which we can find out the number of mangoes. So there are various ways of solving such problems. Basically, this has formed the foundation for the evolution of matrix. Well, before we move to the history of matrix, the answer to the above problem is 33 mangoes, 36 oranges and 37 apples were available in the fruit market. If you had cracked, you would have got 250 grams of your favorite fruit. Come, let's step into the history of matrix. We will see how matrix have evolved over time. Welcome to Marda, and I am Angayar. Matrix, one of the most powerful mathematical tools, has been playing a crucial role since ancient times, and more so in the modern civilization too. As we could see, it stretches back to 300 BC, and till the early 1900s it has undergone its own ups and downs and a bit of quiet time as well. So we could see that since time immemorial, whenever there is a problem with say 2 or more variables or say unknowns with a given set of known parameters, scientists have resorted to using the array of numbers in a specific pattern. That is, beginning with a known parameter, and either by eliminating or substituting or with some assumptions, we try to arrive at the unknown with some slight variations of errors. Interestingly, contrary to the popular belief that learning mathematics is futile, long history proves that whenever challenges emerge which require solutions, mathematics consistently proves its value by helping people in solving a wide range of real-world problems. Say for instance, more than 2000 years ago, Babylonian civilization has used elimination method to solve linear systems of 2 equations with 2 unknowns. And some of these in fact are preserved in clay tablets which survive till date. For example, there is a Babylonian tablet from about 300 BC that talks about a problem with 2 parameters. The problem goes like this. There are 2 fields whose total area is 1800 square yards. The field 1 produces grain at the rate of 2/3 of a bushel per square yard, while the second field produces grain at the rate of half a bushel per square yard. If the total yield is 1100 bushels, what is the size of each field? This problem shows the first evidence of solving linear systems, specifically linear systems of 2 equations with 2 unknowns. In fact, they have used a systematic elimination by first equating the variables, then substituting it with an error, which yielded values above and below the average value, and evaluating the error value and substituting it back into the variable. Finally, they got the result. And it is clear that modern elimination method is faster than the Babylonian method, but it is still evident that the Babylonians were very clever in discovering a method to solve such systems at all. Then we also could see evidences where ancient Chinese have adopted a similar method sometime parallelly during the period of this Babylonian civilization. That is, this we could see that it is somewhere between 200 BC and 100 BC. Chinese also have made significant contributions to the study of linear systems. In fact, in their mathematical text, 9 chapters on the mathematical art, chapter 8 of the book is totally dedicated to solving real life problems like calculating yields of grain, numbers of domestic animals, prices of different products, and so on and so forth by solving linear equations. The technique given in this particular chapter for solving these problems is clearly elimination, which is exactly the same as the so-called Gaussian elimination in the West. For example, problem 1 in the chapter states as follows. There are 3 grades of grain: top, medium, and low. 3 sheaves of top grade, 2 sheaves of medium grade, and 1 sheaf of low grade amount to 39 kgs. Just for understanding, I have made the quantity as kgs, but in Chinese, they refer to it as duos. Next is 2 sheaves of top grade, 3 sheaves of medium grade, and 1 sheaf of low grade amounts to 34 kgs. 1 sheaf of top grade, 2 sheaves of medium grade, and 3 sheaves of low grade are 26 kgs. The question is, how many kgs does 1 sheaf of top grade, medium grade, and low grade grain yield respectively? And we could see that in the book, the solution is given right after the problem. And it goes like this. Yield of low grade grain is 2.75 kgs. Yield of medium grade grain is 4.25 kgs. Yield of high grade grain is 9.25 kgs. So it's quite obvious that matrices has been in use for more than 2200 years for solving such real life problems. But interestingly, the term matrix wasn't coined until much later, and the ancient Chinese method could be used to solve problems with up to 6 equations and 6 unknowns. It was actually a versatile technique that helped them find solutions to various problems, just like the Babylonians. And this was hugely popularized by Liu Hui, who wrote commentary for the 9 chapters on the mathematical art book. This revolutionary method developed by the ancient Chinese was not discovered elsewhere. And for a long time after this, we could see that it was a bit of a silent time for the matrix front. Yes, it was about closely to 2000 years later only these methods got resurfaced. That was during early 1800s. So fast forwarding to modern times, we could see the refined techniques for solving systems of linear equations, but which was very much similar to the Babylonian and Chinese method. It was during 1545, Cardan gave a rule for solving a system of 2 linear equations. Then followed by that, a Japanese mathematician in 1683 named Seiki, he wrote method of solving the dissimulated problems, which contains matrix methods. It was actually written as tables in exactly the way Chinese and Babylonians had written, and Seiki introduced the concept of determinants, but he didn't name it. The first appearance of a determinant in Europe was 10 years later. In 1693, Leibniz came up with notation of determinants and also studied coefficient systems of quadratic forms, which actually led naturally towards matrix theory. And in 1750, Kramer gave the general rule for n by n systems, And in 1772, Laplace discussed the solution of systems of linear equations without actually calculating it. And sometime in 1773, Lagrange studied identities for 3 by 3 functional determinants. But it was in 1801, another brilliant mathematician named Carl Friedrich Gauss was the one who cracked the mystery of determinants. I hope Gauss loved puzzles just as much as he loved mathematics. He discovered that by calculating the determinant of a matrix, one could find if the system of equations had a unique solution or not. And yes, he was the first to coin the word determinant while studying quadratic forms. In the same work, Gauss laid out the coefficients of quadratic forms in rectangular arrays where he described matrix multiplication. Though Gaussian elimination first appeared in the Chinese text, but it was Gauss who used to study the orbits and various other applications using these matrices method. So actually he obtained a system of 6 linear equations and 6 unknowns. And he also gave a systematic method for solving such equations, which is precisely the Gaussian elimination on the coefficient matrix. Then it was Cauchy in 1812 who used determinants in its modern sense. He came up with results like minors, adjoints, cofactors, and so on. In 1841, Jacobi made the idea of a determinant widely known through his publications on determinants. It was Arthur Cayley who published the theory of determinants in 1841 and whose major contribution was in developing the algebra of matrices defining addition, multiplication, scalar multiplication and inverses. But it took a slightly longer time to become an accepted theory later. Though the concept of matrix has already been in use, but the first to use the term matrix was James Joseph Sylvester in 1850. The term matrix, which is derived from a Latin word mater, meaning mother or womb, or it could also be referred to as source, origin. And since Sylvester understood a matrix as an object giving rise to several smaller matrices, he named the arrays of numbers as matrix. And in 1907, Borscher brought matrix within mathematics, followed by English mathematician Cullis, who was the first to use modern bracket notation for matrices in 1913. But finally, it was Turnbull's book on the theory of determinants, matrices and invariants, which was the first of its kind book on matrices. Later in 1930, Turnbull and Aitken book became so influential and popularized matrix. Then Mirsky's An Introduction to Linear Algebra in 1955 helped matrix theory reach its present major role in as one of the most important undergraduate mathematics topics. Thus, it is evident that though the name matrix is roughly just say 170 years old, but the concept to solve systems of linear equations have been there since Babylonian civilization. With its extensive history, it's clear that matrices play a significant role across various fields, with its own algebraic operations to the concepts of matrix, inverse, using determinants, and so on. Especially in today's digital world, matrices find huge applications, say in the field of analytical geometric applications, like whenever you want to magnify a picture or rotation or reflection through a plane. And we just saw the history of matrix being used in solving system of linear equations, where economists use matrices for various applications like inter-industry economics or business studies or sales and marketing, for social accounting, and so many examples are there. And matrices are also used in communication theory, network analysis, as far as electrical engineering field is concerned. And they're also used in very sensitive field like say cryptography, where encryption and deciphering messages are done using the concept of matrix inversion. The applications of matrices appear both fundamental and essential in addressing diverse problem dimensions. And that is the story of matrices and determinants from the ancient civilizations to the brilliant minds of Sylvester and Gauss. Matrix has been an essential tool in solving different types of real world problems. So the next time you are in the midst of a challenging equation, remember the power of matrices and determinants. I hope you enjoyed this quick journey into the history of matrices and determinants. Don't miss the next segment on matrices. Very best to you all.